So here on this page, we're trying to find the derivative of y when it is written as a function raised to the exponent of another function of x. And how do we attack these? Well, once again, logarithms come to save the day. So if I'm trying to find the derivative with respect to x of this function, and I have a function to a function, how can I bring that function down out of that exponent? Well, if I take the natural log of both sides of my equation, now properties of logarithms lets me pull this down. So I have ln y equals ln x over x. So now I can differentiate this. It's now implicit differentiation because I have a function of both x and y. So let's see, my left side differentiates to be 1 over y multiplied by y prime. And this is, I'm going to do a quotient rule. So low d high minus high d low, square the bottom, and away we go. So first thing I see that happens here is this x and 1 over x cancel with each other. So that just leaves 1 there. So I have, let's see, 1 over y prime equals 1 minus ln x over x squared. Well, how do I isolate y prime? I multiply each side by y. That cancels, and I'm left with y prime equals this quantity, this rational expression, multiplied by y. But I cannot leave my answer in terms of x and y because my original problem was an explicit function, so my answer needs to be an explicit function. Well, what is y in terms of x? It is x to the 1 over x, and I'm going to go ahead and multiply that by my numerator, and I'm going to leave my answer like this. So logarithms, specifically natural logarithms, help us to take derivatives of functions that involve exponents. So let's go ahead and leave this one as a warm-up. So when we have a function to a function, logarithms to the rescue. Okay, let's keep moving on.